Lesson 81, solving inequalities with variables on both sides. So we've been looking at solving inequalities, and we are trying to get the variable by itself. And remember, when we multiply or divide by a negative number, we flip the symbol. So our examples today, you'll see we're going to have variables on both sides. And so we're going to need to solve just like we did with two variables on both sides of an equation. The only difference is we have an inequality symbol in our problems today. So here we need to get all of our x's to one side. So instead of a negative 5x over here, I'm going to add 5x to both sides to get all my x's to the left. And if I'm going to move my x's to the left, that means I need all the other numbers to the right. So I'm going to subtract 7 on both sides. And now I add straight down and I get 7x is greater than 14. Now to get x completely by itself, I just divide by 7 on both sides, and I get x is greater than 2. And now I can graph my inequality. Greater than, so it's an open circle. Greater than means it goes to the right. Next one. Here we have fractions involved with it. You can either solve it with the fractions, or you can remove the fractions by multiplying by the least common multiple. I'm going to multiply every term by the least common multiple for 8 and 16. And the least common multiple would be 16. So I'm going to multiply each term by 16. 16 divided by 8 is 2. 2 times a negative 5b is a negative 10b. 16 divided by 16 is 1. 1 times 5 is 5. 16 divided by 8 is 2. 2 times b is 2b. And then 16 divided by 16 is 1. 9 times 1 is 9. Now you can see we just have integers left over. It'll be a little bit easier to solve. So I get my b's to one side. So I'm going to subtract 2b on both sides. And I'm going to subtract this 5 on both sides. So I can have all my b's together. And I'm left with negative 12b is greater than or equal to a negative 14. Now to get b completely by itself, I divide by a negative 12. And I'm left with b. And because I'm dividing by a negative, I flip the symbol so it's less than or equal to 14 divided by 12. I can divide this by 2 halves, and I would get 7/6. And remember, a negative divided by a negative is positive, so I have a positive 7/6. And so on my number line, I'll have 7/6. I have a filled in circle because it has a group equal to parts. Less than means it goes to the left. Next set of problems. 4x plus 1 is less than negative x plus 11. To get my x's to one side, I'm going to add 1x to both sides and then subtract 1 on both sides. And I get 5 is less than, 5x is less than 10. To get x completely by itself, divide by 5 on both sides. I'm left with x is less than 2. Draw my number line. Open circle on 2. Less than means going to the left. This next one is the same as our previous one. To get rid of our fractions, we'll need to, actually for this one, I'll keep the fractions in there. So if you're one that wants to keep the fractions in there, you can keep the fractions in here. So first we need to have common denominators. But actually right now for this one, I'm going to get all my a's to one side. So I'm going to subtract 2a over 5 on both sides. And when I do that, I end up with a negative 5a over 5 plus 7/10 is greater than or equal to a negative 9/10. Subtract 7/10 on both sides. And over on the left-hand side, negative 5a divided by 5 is just a negative a. Greater than or equal to a negative 16/10. And to get a by itself, I divide by negative 1. We're really multiplying by a negative 1 over 1. This will give us a positive 16/10. I can reduce that by 2/2, and I would get 8/5. For my inequality, since I'm divided by a negative, a would then be less than or equal to positive 8/5. Now my number line, 8/5 would be here. I have a filled in circle on 8/5. Less than means going to the left. There's just another way of doing that. It worked out that I didn't have to change any denominators because they already had common denominators. Next set of problems, solve and graph these. Here we need to do some distribution first before we combine. So 2 times x is 2x. 2 times negative 8 is a negative 16. Minus the 3x is greater than 6. Negative 3 times 2x is a minus 6x. Negative 3 times 4 is a negative 12. Combining like terms, 2x minus 1x, or minus 3x is a negative 1x. Minus 16 is greater than 6 minus 12 is a negative 6, minus 6x. Get all my x's to one side, so I'm going to add 6x to both sides, and then add 16 to both sides. And I'm left with 5x is greater than 10. To get x by itself, I divide by 5. Left with x is now greater than 2. To graph it, open circle on 2, greater than means to the right. Next one here, I'm going to combine like terms. 4z minus 8z is a negative 4z plus 1 is greater than 3 plus 4 is 7 minus 2z. To get the z's to one side, I'm going to add 2z to both sides. I'm going to subtract 1 on both sides. And I'm left with a negative 2z is greater than 6. Yeah, z by itself, I divide by negative 2. Because I'm dividing by a negative 2, I flip the symbol so it's less than a negative 3. Draw my number line. I have an open circle on negative 3. Less than means it goes to the left. And a couple other ones here. Simplify before we can combine. So 3 times 5k is 15k. 3 times a negative 4 is a minus 12. It's less than or equal to 30k plus 3. Now I can get all my k's to one side, so I'm going to subtract 30k on both sides. Then I'm going to add 12 to both sides. And I'm left with a negative 15k. It is less than or equal to 15. To get k by itself, I divide by 15 by a negative 15. I'm left with k. Because I'm dividing by a negative, I flip the symbol, negative 1. So k is greater than or equal to negative 1. Number line, we have filled in circle on negative 1. Greater than means to the right. And we have 4 times x, which is 4x. 4 times a negative 1 is a negative 4. Minus 2x is less than or equal to 6. Negative 5 times x is minus 5x. Negative 5 times 2 is a minus 10. 4x minus 2x is 2x. Minus 4 is less than or equal to 6 minus 10 is a negative 4. minus 5x. Get all my x's to one side. I'm going to put them to the left. So I'm going to add 5x to both sides. And then I don't want this minus 4 here, so I'm going to do the opposite. So add 4 to both sides. And I'm left with 7x is less than or equal to 0. The x by itself, I divide by 7. I'm left with x is now less than or equal to 0. On a number line, since it's got the equal to sign, it can equal 0, so filled in circle, less than means to the left. And our next one, some special cases. We have two vocabulary words. Identity just means an inequality or equation that's always true. And then a contradiction, where the inequality or the equation is never true, also known as false. So here, we'll solve everything the same way, and you'll notice that it will always be true or it will never be true. And so we'll label them as identity or contradiction as well. So it's combined like terms. 3x minus 1x is 2x plus 4 is greater than 2x plus 7. To get our x's to one side, I'm going to subtract 2x. And I'm left with 4 is greater than 7. Now 4 is never going to be greater than 7, so we would call this a contradiction or a false, because 4 is never greater than 7. And if you would have went further, if you would have subtracted 4 on both sides, you would have had 0 is greater than 3. That also would be false. Next one, distribute the 3. We got 3 times 2y is 6y. 3 times a negative 6 is a negative 18. Less than or equal to 6y plus 4. Combine like terms, or get the y's to one side, so I'm going to subtract 6y on both sides. And I'm left with negative 18 is less than or equal to 4. And that is always true, so we would say this is an identity or true. If you were to get the negative 18 to the other side, you would have 0 is greater than or equal to, we'd have to add 18 to both sides, you would have had 22. So you would have 0 is less than or equal to 22, which would also be true. Next one, 2x plus 1 plus 2x is greater than 4x plus 10. Combined, I got 4x plus 1 is greater than 4x plus 10. So just like the other ones, you'll notice that my x terms are the same on both sides. And the rest of it is not the same. So that is a clue when you're solving that it's either going to be a contradiction or an identity. So I subtracted 4x on both sides. I'm left with 1 is greater than 10. 1 is never greater than 10, so this is a contradiction. Or you would say false. One on the right here, 1x plus 3x is 4x plus 5 is greater than 4x plus 19. So here you have your 4x's the same, so subtract 4x. Left with 5 is greater than 19. That is never true, so contradiction again. Or you could say false. And some application problems. If the trend continues, so in the chart above, in which year will the number of registered Bernese Mountain Dogs be equal to or exceed the number of registered Rottweilers? So here we need to create our inequality. So we're going to start off with how many Mountain Dogs were registered in 2006, so that's 3,700, plus they gain 300 per year, so I'm going to have 300y. And it says to be equal to or exceed, so that means greater than or equal to Rottweilers, which they had 1,400 or 14,700 in 2006, minus, because they have a negative sign right here, minus 1,900 per year. So now we solve, get all my y's to one side, so I'm going to add 1,900 y to both sides. I'm going to subtract 3,700 to both sides. And I'm left with 300 plus 1,900 would be 2,200. Y is greater than or equal to 11,000 here. And then to get 2,200, or y by itself, I divide by 2,200. And 11,000 divided by 2,200 would give us 5. And so we would have y is greater than or equal to 5. So at least 5 years is when the number of registered Bernese Mountain Dogs will be equal or exceed. So it says in which year. So now if we add the 5 to 2011 or 2006, so 2006 plus your 5 years would give you in the year 2011 is when they would first exceed the amount. And the last one. The tables show the average number of cell phone minutes used by Ara and Lexi. If the trend continues, in which month will Ara's average minutes be equal to or greater than Lexi's? So Ara's got 4,000 plus 500 per year. Instead of years, just use months because everything is in months because this is only going from January to May. It has to be greater than or equal to, and Lexi's is 12,000 minus 500 a month. So let's use the watt and the m. So I get our m's to one side, so I add 500 m to both sides. I'm going to subtract 4,000. I'm left with 1,000. M is greater than or equal to 8,000. Get m by itself, divide by 1,000. So m has to be greater than or equal to 8, which would be 8 months. But they're asking in which month will Ara's average minutes be equal to or greater. So I start with January and then add 8 months. From January and add 8 months, that would be September. So in September is when her average would be greater than or equal to Lexi's. So that is our lesson today on solving inequalities with variables on both sides.